Alright, so we've collected the data, transmitted it via radio, visualized the data on an LCD, learned how to use a Wi-Fi module ESP, and learned how to post data to the cloud using the Thingspeak service, as well as introduced the watchdog in order to make our sender collect the data, send it, go to sleep to save power, and then wake up, collect more data, send it again, and go to sleep again. So now we're going to actually use the watchdog and Thingspeak all together and basically wrap up this project. So let's go ahead and put it all together. Alright, so just to review, we've got a sender, which is our Nano, which has our DHT11, and the receiver, which is our Uno. And what we want to do is make the sender sleep, because it's going to be powered by a battery pack. Alright, so and this is our setup. So we have the warehouse, which is remote. It needs to operate autonomously on a power source that can be recharged and very slowly used up. We don't want it to power down. So let's just review our original transmit code, which was actually pretty simple. So we had all the includes and the defines for the radio and for the DHT11, and we defined a few radio objects, and basically the package was a new sort of variable that we could kind of use to create two variables inside of it, or to nest them. Then in the setup we would initialize our serial monitor, our DHT, and our radio, set a few parameters over to the radio, and then in our loop we would basically count 1 second since the last time that we saved our current millis. Every time that the second elapsed, we would call the send function, which does this. Reads data, writes it to the radio, which obviously sends it to the receiving radio. We would print some data onto our serial monitor just for debugging purposes. We can get rid of that. And we would go ahead and print an error message if there was one. So what does the new transmit code look like? So we want to include the AVRs, which are up at the top, the first 4 lines. The rest is the same all the way down basically to line 27, which is where we added that famous NBR remaining, which is if you recall, was the number of times or cycles that we wanted to count 8 seconds. Because 8 seconds is the max allowed time to sleep. If we want to tell the MCU to sleep for more than 8 seconds, we got to do multiples of 8. Then we would go ahead and just add the interrupt service routine function, which is the ISR on line 35, and the configure WDT, where we configured our watchdog to tell it how we wanted to sleep, which was for 8 seconds in this case, line 48 if you recall. And once we had this watchdog configured, we would actually incorporate it into the rest of the sender code. So that code looks like this. The sleep function is where we're actually going to tell our MCU to sleep. And in the setup, all we're doing is adding a call to configure the watchdog, which is on line 95. That's the only difference right now. So when it sets up, when it runs for the first time, it's going to know that we're going to use this watchdog functionality. So it's got to go to that configure WDT function to check out what it is that we want the watchdog to do. But then it goes into its normal loop. So what does it do? It goes to sleep immediately for 5 cycles. 5 cycles of 8 seconds each, so a total of 40 seconds. And then when it wakes up, it comes back to this point. So it goes to sleep immediately on line 100, and when it wakes up, it comes back to line 102. And it goes to the send function, which, as if you recall, it would collect the data, write it to the radio, and then just print out some message. Okay, so we've introduced some a graph here where we could compare the 2 modes of functioning. The first one, the top blue line, is with the AVR, the voltage with the AVR after a certain number of hours, and the bottom orange line is the voltage of our MCU without the AVR power savings functionality. As you can see, power drops off pretty quickly in a non-AVR. Okay, so we've got the sender working, and now let's go ahead and look at the receiver. We're going to need to download a library, and this is the Thingspeak library, because this is the one that's going to post to the Thingspeak cloud. Okay, so here we're also downloading the Wi-Fi-Esp library. So those are the two libraries that we downloaded, and we're going to use them in our new receiver code. So the new receiver code includes this Thingspeak library and the Wi-Fi-Esp library, which are lines 26 and 27, as you can see. We've added another include for secrets, which is just a file or a tab within your own sketch where you're going to write down your secret SSID and your secret password so that you don't have to expose that data when you're looking at the code, such as this case right now. So that's the secret one simply is a backdoor reference to where the SSID and password is stored. So it's no big deal there, and we'll take a look at that as well. So we've included the two new libraries, Thingspeak and Wi-Fi-Esp, and we are ready to now connect the Thingspeak code, which is actually going to post to the cloud, which we saw in a previous video how to do. So we go over to the setup, and nothing new. We've moved the radio code and the LCD code onto a function by itself, which is setup radio, just for clarity's sake, not much else. Don't worry about those random numbers that I created over there on lines 57 through 62. That was just for generating random data. It was actually from a tutorial code that I found online. We're actually not going to use those because we're going to use real data. There are two things up top, lines 55 and 56. One is the channel number and the other one is the API key. You get those from Thingspeak, and those could also be moved over to our secrets file, but I didn't think it was that necessary. Oh, actually they are. Yes, I did move them to the secrets file. Okay, then we have the loop, which basically gets the data and then shows it. And the get data hasn't changed, and show data hasn't changed. Okay, so let's go ahead and see what does happen. Here is the post data cloud. So this is the part of the receiver code that actually posts the data. And this uses the Thingspeak library and the Wi-Fi-Esp library. So we're setting some baud rates. We're using the Wi-Fi object init function. We call the status, and then we go ahead and we use the Thingspeak library on line 126 where we begin the Thingspeak client so that we can actually post data to Thingspeak service. Then we go ahead and we do some more Wi-Fi status stuff and begin, and we go ahead and actually set the data on lines 139 and 140. So this is the line, these are the two lines that are actually posting our received data to the Thingspeak cloud. Alright, and then this is some code all the way from 142 down to 150 to 149, which is not really necessary, so don't worry about that. And this is that helper function for the setting the ESP baud rate that just basically came included with the code. It was a sample code that I got from Thingspeak, so that's all it's doing right here. Okay. Okay, and just so that you guys can see what that secrets file looks like, it's basically just a define. So it's a variable that is stored in a different file than the one that you are showing others. Okay, so here is that Thingspeak code again. Well, actually not the Thingspeak, because this is the sender. And as you can see, it's gone even lower. It's now down to 0.1. So it's definitely saving quite a bit of power now. And the only thing left to do now is actually test it out in the field. And I kind of wanted to talk to you guys about that because there's two things that I ran into that I wanted to make sure to mention that have to do with, there it is, it jumps up to 0.2 and then it comes back, with the actual finishing touches of this project here. So number one is that we've got our sender going to sleep, saving power. That's pretty simple, and it'll keep doing that for however many cycles we tell it to, 8-second cycles. And then we have the receiver now, which is actually posting data to the Thingspeak cloud. But when I actually moved this out into the field, I ran into a couple of issues that I thought were important to mention, so I'm going to go ahead and mention them right now. So the first one was At a certain time, the NRF receiving module would, for some reason, stop receiving. It wasn't the sender, because I could see the sender operating, and I could not see the receiver, which was actually connected to the serial monitor, receive anything else. And the way I debugged it further was I would reset the sender with the reset button on the MCU, and nothing would actually change. I would still not receive any further data. I would reset the receiver MCU, the Uno, and I would start getting data again. So I had to add a watchdog code to reset the Uno after a certain amount of time as well. So that was the actual, the second reason to use watchdog, not to save power. So the watchdog is not biting to wake us up. The watchdog was biting to actually reset the MCU in case a certain amount of time had elapsed and the MCU had not padded the watchdog. So the watchdog would bite it back and reset it, and that would be the equivalent of pressing the reset button on the receiver, and then I would start receiving my data again. The second point worth mentioning is the line of sight. So they're very cheap radios, and they do have quite a bit of distance. In this case, 100 meters. There's the other PA-LNA version, which goes up to 1100 meters, but there's still line of sight, so you do need line of sight. And there was a point where I had a metal gate in between the sender and the receiver, and that was obviously a big no-no. No data was getting through. And then the other one was the actual orientation of the antenna, because the antenna is on board this module, as you can see here, and that means that the antenna of the sender has to be facing the general direction of the antenna of the receiver. If it is not, as it was in this case, the antenna was actually, for some reason, facing straight down into the ground. There was line of sight. I had already fixed that issue, so the two receivers had a direct line of sight between each other, but the antenna on the sender was actually facing down into the ground, so that was also causing issues. So I just wanted to mention those two things, because when you do take this into a real-life project, you're going to have to work out these kinks, because it's part of the user experience. Alright, so this has been a pretty big project, I know, and I ran it, I presented a lot of stuff, and I hope it wasn't too overly complicated. If it was, go ahead and drop some comments, or email me, or tweet, or whatever, and I will try to address those issues on an individual basis. So, alright, I hope you enjoyed this. This was a complete project again. This was number 2, complete project. And there's quite a lot of details that we went into, and I hope to do a better job covering the next project, number 3. So I'll see you guys in the next video, and don't forget to like, share, and subscribe. See ya.